So class, now we are looking at the 7.3. Okay, application of the factors affects the rate of reaction in our daily life. Okay, now we look into how the factors that affects the rate of reaction. We have 5 factors altogether, right? Okay, so we look into one by one. How is the application of these factors that will affect the rate of reaction? Okay, so first one, we look into the combustion of the charcoals. Okay, arang kayu. So this one, normally you will see during barbecue, right? Okay, the BBQ in our let's say in birthday party and so on. Okay, we do the BBQ. So combustion of the charcoal. So smallest piece of the charcoal, it will have what exposed to the air or oxygen gas. If it is smaller, okay, smaller piece. Okay, so how about the total surface area class? Okay, what happens to the total surface area if it has a smaller pieces? So what happens to the total surface area class? It will have a bigger or larger, bigger or larger total surface area exposed to the air or to the oxygen. Okay, so meaning that more oxygen it is exposed to the oxygen, right? Okay, now number 2, smaller piece of charcoal, it will absorb what? Absorb more heat. Okay, more heat. So therefore, the rate of combustion for smaller charcoals with oxygen is higher, higher. Okay, so here we mentioned about the rate, right? Rate of combustion. So for the smaller charcoals with oxygen, be higher. Okay, so when we talk about the rate, we will use the higher. Okay, not the faster. So this one, smaller piece of the charcoal. Okay, so beside charcoals, actually, sometimes you will see the question, okay, you can change it to meat. Okay, daging, meat also the same. Okay, or anything with the smaller size. So actually, you can use the same points to explain in your exam. So this one is the application. Any question for this about the size or total surface area? Okay. Next, we are looking into this cooking food in a pressure cooker. So which factor is affecting this one? Class, what factor? Which factor now? Anyone? What factor affect this using the pressure cooker class? What is the factor? Is that? Anyone? Okay, so pressure cooker. So the factor now is a not is a pressure, is a pressure. Okay, but pressure indirectly it will affect the temperature. Okay, but the main one will be pressure. Okay, so because here you see the pressure cooker, so that's why the factor affecting now will be the pressure. Okay, now we look into the explanation here. Okay, good try, Crystal. So in a pressure cooker, the high, because inside the pressure cooker, the pressure is higher. Okay, enables the water to boil at a higher temperature. Okay, so that's why I say indirectly you affect the temperature. Then the normal boiling point. So therefore, the food can be cooked faster, faster in a pressure cooker. Okay, but the main thing here, we still focus the higher pressure, higher pressure. Okay, so that's why we can use the pressure cooker to cook the food faster. Okay, it can be cooked within a shorter time. Okay, so this one is second one. Okay, third one, storing a food in a refrigerator. Okay, so why we put our food inside the refrigerator? So what the factor now? I think this is obviously because temperature, right? Temperature. Okay, so the temperature in the refrigerator is what? Lower, right? Okay, lower than the room temperature, correct? Now, if the temperature is lower, so the activities of the bacteria become slower, not that active actually. Okay, so therefore the food, it can last longer. Okay, because the decaying reaction that destroy the food is slow down. Okay, so slow down. Is that okay? So because of the temperature, okay. Sometimes you see, okay, if lower temperature, okay, the bacteria becomes less active. So less toxic. You can also mention about less toxic is produced by bacteria. Okay, also accepted. Okay, so there are three application, okay, that commonly asked in the exam. Okay, so first one is the size. Okay, sometimes you see the meat now, okay, charcoal. Number two is the pressure cooker. Number three is the refrigerator. Okay, then sometimes the question will ask you why the food store in the kitchen cabinet it will spoil faster, okay, compared to the refrigerator. Okay, so the explanation actually understand. Okay, then kitchen cabinet, the temperature is higher. Okay, now number two, okay, complete the table. Okay, here there are some industrial processes. Okay, the products and then optimum condition. Okay, this one I'd like you to record down. Okay, there are four industrial processes. Okay, they are commonly used or quite famous, in the exam. Okay, so this one you can record down. Okay, so first one is the manufacturing of the margarine. Okay, so industrial product will be the product is the margarine. Okay, so the optimum condition will be temperature is 180 degrees Celsius, and then the catalyst used is the nickel. Is the nickel. Okay. So number two, the Haber process. Okay, the industrial product will be ammonia. Ammonia. Temperature 450 degrees Celsius. Atmospheric pressure. The catalyst used is the iron. So you record down. Third one is the contact process. Contact process. The product is sulfuric acid. Sulfuric acid. Temperature same as the process. Okay, but the pressure is 1 atmospheric pressure. The catalyst is vanadium 5 oxide. Okay. Okay. Then last one will be Oswald process, producing the nitric acid. So temperature, this one higher, 850 degrees Celsius. Pressure 5. Okay, the catalyst is the platinum. Okay. So in other words, most of the factors affecting the industrial processes are the catalyst. Okay. All this needs the catalyst. Okay. So next we are going to see the last part of this chapter, collision theory. Okay. After this, I will use another note that I post in the group so that we can use that one to explain the collision theory. Okay, never mind. We look into this one first. So collision theory, okay, they states that for a chemical reaction to occur, the reacting particles, the particles must what? Okay, first one collide with each other. Okay, collide with each other, berlanggar. Okay, can. So that the breaking and formation of a bonds can occur. The first one. Number two, it possesses energy that equal or more than the minimum energy called activation energy. So meaning that it must be overcome the activation energy. Okay. More. Okay, more than activation energy. Like say the activation energy is 100 kilojoule. So when they collide, it needs to produce the 100 or more than that. Then it will produce the products. Okay. Now, another one, it must be collide with correct orientation. Okay, what is this mean? Okay, it means that the way they collide must be correct. Okay, for example, I show it to you. Okay, for example, okay, let's say this is the hydrogen H. Okay, and then this one is the chlorine. Chlorine, Cl. Okay, when they collide like this, if this one they collide, okay, the orientation is wrong. Okay, wrong orientation. So no products. Okay. So correct orientation is like what? Okay. So let's say here, okay, hydrogen like this. Okay. Chlorine like this. Okay. So when they collide, okay, they collide each other. Okay. Then if it is correct orientation, then they will having the bond breaking and bond formation. So the hydrogen you combine with the chlorine. Okay. It forms a new product. Okay. Then the new bond is formed. Okay. So this one, got the product. Okay. So the orientation they collide must be correct. If like this, if they collide, will be wrong orientation. So no products. And then another one, the collisions, okay, they will produce the energy. That energy must be more than the activation energy. If it moves very, very slow, then will be no product also. Okay, class. So here is the energy profile diagram for endothermic and exothermic. Okay, endothermic and exothermic we will discuss in details in Form 5. Okay, exothermic is the release heat. Okay, release heat to surrounding. Endothermic is absorb heat. from surrounding. Okay, exo and endo. So if you look into here, so because it releases heat, the reactants, okay, the energy is higher compared to the products. The energy is lower in the products because heat is released, right? So the energy, okay, I think in our last lesson I have drawn for you already. I've shown you. So if it is from reactants to the peak of this one, peak of the curve. Okay, so this one is the activation energy. So for endo, absorb heat. So energy product for the energy content for the product is higher. It's higher compared to the reactants. Okay, but the activation energy still from the reactants to the peak of the curve. A lot of students they feel that it is from here. Okay, it's wrong. Must be from reactants to the peak. Okay, reactants. So here reactants is here, not the product. It's a reactants to the peak here. Okay. Yeah. So this one we call it is a energy profile diagrams. Energy profile diagrams. Okay. Okay. So in order to answer the essay question, especially in the essay question in the exam. Okay. Now I show you another one. Okay. So for this one. Okay. Now we look into the steps to compare and explain the factor affects the rate of reaction between two experiments. Okay, using the collision theory. Okay, so before we look into the explanation here, okay, I would like you to look into another one here. Okay, so for this one, okay, so there is one thing I would like you to focus here will be the ionic equation. Okay, so still remember how to write the ionic equation correctly. Okay, so remember for ionic equation, okay, so solid, liquid, and gas, you maintain it, maintain it. Okay. So solid here refer to insoluble salt also, insoluble salt. Okay. So as long as it is insoluble salt, it is solid lah. Alright. Liquid and gas, you maintain it. Don't separate it. Okay. Then acid, alkali, or soluble salt. Okay. So you ionize. You ionize. Okay. Let's see. So magnesium and hydrochloric acid, okay, produce the magnesium chloride and hydrogen gas. So here, magnesium is a solid, is a powder, right? It's a solid. Okay. Hydrochloric acid is an acid, so we need to change it to ions, right? So meaning that you change to hydrogen ions and then chloride ions. Okay, So this one 2. Okay, magnesium chloride is soluble or not, class? Magnesium chloride. Is it soluble? Salt? Is it soluble, class? Magnesium chloride soluble or not? Chloride, PaH, right? So magnesium is soluble. Okay, soluble salt. So if soluble, meaning that we change it to ions, you ionize. So chloride. Okay, hydrogen is a gas, maintain it. So magnesium is a solid, so maintain it. Okay. So here, okay. So same ions, we cancel it. So chloride cancel. So the maintained one, magnesium and hydrogen. So you get this one. Is that okay? So this is the ionic equation. So why we need to write the ionic equation? Because in the collision theory, we need to find out what are the particles they are collide with each other in the reaction. So what ions they are collide? This one, these two, the reactants. So magnesium is a solid, right? So with magnesium, you need to mention atoms. Okay. Then hydrogen, H positive. So hydrogen ions. You have to mention, mention correctly. Okay. So magnesium atom collide with hydrogen ions. Any question? You can get what I mean here. Yeah. You can see here the second one almost the same, just the acid is different here. Acid is different here. So magnesium nitrate also soluble. Nitrate salt all are soluble. Magnesium and hydrogen maintain. So you can see hydrogen ions for the acid, no matter what acid it is. So the ions that are present must be hydrogen ions for acid. You just remember. So here, this one also magnesium collide with magnesium atom collide with hydrogen ions. Is that okay? So next one, zinc with the acid again. You see, acid again. So still the same. See, zinc collide with hydrogen. Zinc atom collide with hydrogen ion. So zinc atoms, hydrogen ions. Okay. Then how about this? Yeah, all this you can record down. This one is an ethanoic acid. This one looks like a lot of hydrogen, and then oxygen. Okay, but in actual fact, as long as it is acid, hydrogen still the same, hydrogen ions. So zinc collide with zinc atoms collide with hydrogen ions. Okay, Anna? So these are the popular questions now. You will see that no matter how the question change, they will use these few types of example only. Okay, and now this one, be careful here. Okay, now calcium carbonate with hydrochloric acid produce the calcium chloride, water, and carbon dioxide. Okay, so here calcium carbonate is a solid, solid, so it maintain, solid maintain. And then hydrochloric acid, still the same, hydrogen ions. Okay, so meaning that the particles that are collide here, okay, hydrogen ions still the same, okay, but for the calcium carbonate, okay, so calcium carbonate is the exception, exception. So you just mention about calcium carbonate. No need to mention atom, molecule, or ions for this. You just mention calcium carbonate collide with hydrogen ions from the acid. Okay, acid is still using the hydrogen ion. So only the calcium carbonate. So pay attention here. We put a star. Okay, so calcium carbonate, no need to mention what is this. No need. Okay, So this one, I think quite popular. Come up few times in the SPM already, but still a lot of students, cannot get this correct. Calcium carbonate no need to put in what it is, atom, molecule, or ions. No need to put. Okay, so calcium carbonate sometimes you see the question will say it is marbles, marble chips. Okay, marble chips. Actually, it's a calcium carbonate. Okay, so next one, this one is the H2O2. So class, what is this? This is not water. Water is H2O. Yeah, this is water. How about this one? This is called hydrogen peroxide. Okay, hydrogen peroxide. Okay, why dash? Because it is in the molecule forms. Okay, molecules form. So molecules form. So there is no ions. So definitely here no ionic equation. Because here there are molecules, right? So in other words, the particles that are collide will be hydrogen peroxide molecules. They will collide with each other. Okay. Okay. Then another one, this one, sodium thiosulfate and sulfuric acid. So again, sulfuric acid is the acid, will be the same, hydrogen ions. Okay. Then this one, sodium thiosulfate, the thiosulfate here, this one becomes the ion. So is called thiosulfate ions. Okay, you collide with hydrogen ions. So this one normally when you will see this, the factor of concentration and temperature factor. Okay, so you will do the two experiments. You involve the factor of concentration and temperature using these two chemicals, sodium thiosulfate and sulfuric acid. Okay, so the ions that are collide will be sodium thiosulfate, thiosulfate ions and the hydrogen ions. So these two, they are collide. Okay, so class, you can see under this here, okay, these three, okay, they are popular. Okay, now we go back to the collision theory. Okay, collision theory. So, okay, there are 4 points actually. If you are given 2 experiments, there are 4 points that you need to mention. Okay, so here already listed out. So in the exam or when you do the experiment, do the exercise, you just refer to these notes. I think this one is very good for you to practice now. Okay, so now class, let's say you know the factor now is the size or total surface area. Okay, the size. We are talking about the size. Okay, so here using the calcium carbonate chips. Okay, so first we mentioned the size of the calcium carbonate chips in maybe experiment 1 or experiment 2 Okay, sometimes you see powder is the smaller size, right? Okay, so size you mentioned first. Okay, smaller. Okay, so this is point number 1. Okay, point number 2. Okay, here next one. Okay, point number 2. So if the size smaller, okay, now what you need to mention is the total surface area for the calcium carbonate in experiment 1 is larger than experiment 2. So this is point number 2. Okay, so point number 3, after you mention about the point number 2, okay, here compare the frequency of collisions. Okay, here frequency of collisions between the number of particles. Yes, these particles you have to see what particles in the reaction actually. So particles here actually you can refer to here. Okay, so for this one class, just now is the calcium carbonate, right? Calcium carbonate with what? With what? With the acid, right? Normally, yes, hydrochloric acid. So if acid, what is the particles that are colliding, class? For calcium carbonate and acid. So acid, remember, acid will be hydrogen ions, right? And then calcium carbonate, just now I mentioned to you already. So calcium carbonate, no need to mention anything. Just mention calcium carbonate, okay? So here, the standard answer, the frequency of collisions between, okay, what particles? Calcium carbonate and hydrogen ions. Hydrogen ions from acid in experiment 1 is higher than experiment 2. Okay, Anna? Okay, so you must take the particles that collide in the reaction based on the ionic equation. Okay, but catalyst does not increase the frequency of collisions between the particles. Okay, then point number 4. Okay, after you mentioned about the frequency of collision, okay, now frequency of here, effective collisions. So this one, the only difference here is this one got effective words. This one, no effective. Okay, so the frequency of effective collisions, okay, between the particles, okay, so particles still the same, calcium carbonate and hydrogen ions in experiment 1 is higher than experiment 2. Okay, so rate of reaction in experiment 1 is higher than experiment 2. Okay, so normally if we are asked to compare the rate of reaction using the collision theory, normally it's 4 marks in the essay, 4 to 5 marks. Normally it's 4 marks. So factor of size. Okay, now we look into the second one. The factor of concentration, concentration. So reaction between the hydrochloric acid with the hydrochloric acid with the zinc. With the zinc. Okay. So first we mentioned about the concentration of the hydrochloric acid in experiment 1 is higher. Concentration higher. Okay. Next point, if concentration higher, what happens? Okay, here, the number of hydrogen ions per unit volume. Okay, so this one standard now for concentration factor. So number of hydrogen ions per unit volume. So because here using the acid now, so acid, hydrogen ions, right? Okay, point number 3, frequency of collision. Okay, the frequency of collisions between the hydrogen ions and zinc atoms, right? It's not discussed already. Zinc atoms. You cannot use the particles. A lot of students write the frequency of collisions between the particles in the experiment 1 is higher. You cannot use the particles. You must mention, specify the particles that collide. Okay, very simple. All are here already. All are here. They won't use other example. Don't worry. So after you mention about the frequency of collisions, then frequency of effective collision. Again, the same thing. Effective collisions between the hydrogen ions and zinc atoms in experiment 1 is higher than experiment 2. So rate of reaction is higher in experiment 1. Okay, how class? So factor size, factor concentration. Any question you want to ask? Any question, Darren? Kansing, okay? Suyang, okay or not? Willie, okay? Adrian? Any question you want to ask? No, no response means no question. Okay, next we look into the temperature. Okay, so temperature reaction between the hydrochloric acid and zinc, still the same, hydrochloric acid and zinc. Okay, so you see which one has a higher temperature? Like say experiment 1 higher, higher temperature. Okay, so next point. Okay, point number 2. Okay, so the kinetic energy of the hydrogen ions. So you mention about the kinetic energy. Okay, kinetic energy of hydrogen ions in experiment 1 is higher than experiment 2. Then after that, the frequency of collisions between the hydrogen ions and zinc atoms is higher. Okay, so frequency of collision. Okay, here you mention about the hydrogen ion, zinc atom will be the same. Then after that, effective collisions, right? Okay, so frequency of effective collisions again, be the same. So you will see, actually the first 2 points only different. The 3 and 4 almost the same, Okay. Then finally is the catalyst, catalyst. Okay, so let's say reaction between zinc and sulfuric acid, Okay. Now copper 2 sulfate, suddenly it is present in the reaction. Okay. So it acts as a catalyst for the reaction. Okay. But in experiment 1, but not in experiment 2. Okay, so copper 2 sulfate, it will lower the activation energy. So this one is different a bit now. Okay, so these two, it lowers the activation energy for the reaction between the zinc and the sulfuric acid in experiment 1. So more colliding particles, it will achieve the lower activation energy. So these two is different. Then for the catalyst factor, no need to mention about the frequency of collisions. Okay, so no need. It replaces with these 2 points. And it lowers the activation energy. So more colliding particles can achieve the the lower activation energy. So directly go to the effective collisions. Okay. So effective collision between the hydrogen ions and zinc atoms in the experiment 1 is higher than experiment 2. So rate of reaction is higher. Okay, huh, class? Now we try to use the 4 points here, okay, to answer the questions. Now for starting, you can always refer here. Always refer here. Okay, always refer here so that you can write the correct points for the collision theory. Okay, we try. Okay, we in our previous lessons, okay, there are some questions that I leave it right. Okay, I say we do it after we talk about the collision theory. Oh, still remember? Okay, I think it's this one. Size, no? Okay, so we look into one by one. Okay, page here. Okay, so set 2 has a higher rate of reaction than set 1. No? Okay, page 137. No? Okay, explain your answer using the collision theory. So we look into set 1 and set 2. Okay, set 1 and set 2. So what is the difference? Okay, class. Set 2 using the powder, right? Okay, using the powder. Now the reaction is zinc, huh? React with the sulfuric acid. Okay, so class, what are the particles that collide here? Anyone, can you tell us? What are the particles that will collide in this reaction? Acid, no need to think too much, will be hydrogen ions, right? Okay. Then how about zinc powder? So what are the particles? Anyone? What are the particles that can collide with each other? Zinc atoms, very good. Okay, zinc atoms. Zinc atom. Oh, zinc atoms. So, class, we use the one we discussed just now. Okay, there are how many points? 4 points, right? Okay, so we try to answer this question. You just follow the 4 points stated there. Okay, to answer this question. So experiment set 2 set 2. Okay, so how to answer this question? Okay, we use the one, this one, we use this one. You can also refer to here. So factor, so we use this one, all the points here. But here, not the calcium carbonate, you change to zinc. All right, you change to zinc. Okay, so we try, I show you one sample. One example, okay. So, okay, so point number 1. Okay, point number 1, the size of zinc, in set 2, is smaller than set 1. Okay, so this is point number 1. Okay, so point number 2, the total surface area of zinc in set 2 is larger than set 1. Okay, so this is point number 2. So point number 3, okay, so we mentioned about the frequency of collisions between what particles? Just now we mentioned already, zinc atom and hydrogen ions. In set 2, is higher than Z1. Okay. So point number 4. The only difference here with point number 3 is just mention the effective collisions. The frequency okay. This one, if a collisions are here is effective collisions. The only difference here. So the remaining is just copy with the set. Okay. So point 3 and point 4 actually quite simple. This one collisions, this one is the effective collisions. The remaining are the same. Okay, just you need to mention these particles. You have to mention it clearly. So 4 marks. 4 points. 4 points, 4 marks. Any question, class? Anything you want to ask? Okay or not? Cannot? Okay. So, okay, next one is the concentration factor. Concentration factor. So now you can use the factor of concentration. Okay, so you try this one. Later we discuss together. This one. Okay, concentration factor. Then after that is the also a concentration factor. Okay, with the same. These two. Okay. But the collecting particles will be slightly different a bit. Okay, later we check. Then this one is a factor of temperature. So temperature, we also do. And then finally is the catalyst. Okay, catalyst. Catalyst, yes. Okay, so there are few questions. You just I just let you try. Okay, how to use the points in the for this one. Okay, you just need to know how to use the points only. Okay, and then the particles. You have to mention. You have to specify it. Okay. So I let you try. Let you try these few questions here. So after this, we discuss together. After this, we discuss together. Okay, class. Now we check the points. See whether you can write it correctly or not. Okay. Now we check this one. The concentration. So set 1 and set 2. Set 2 using the sulfuric acid. No? So sulfuric acid is diprotic acid. Correct? So the concentration is higher. Oh, okay. So we use the concentration factor points to answer this question. So set 2. Okay, so the concentration of sulfuric acid, right? In set 2 is higher than set 1 is the hydrochloric acid. In set 1. Okay. So here you can also mention about this diprotic acid. This one you mention it is a monoprotic acid to show it is the concentration is higher. Okay. So point number 2. So the number of hydrogen ions per unit volume. This one is standard for concentration factor. In set 2 is higher than set 1. Okay. Point number 3. So the frequency again, the frequency of collisions between what particles now, class? For this sulfuric acid and zinc. Acid will be hydrogen ions, zinc with zinc atom, right? Zinc atoms and hydrogen ions, right? In set 2 is higher than set 1. Okay. So point number 4, the frequency of effective collisions. The remaining are the same, so I just write in this one, the effective collisions for point number 4. Now point number 3, collisions, frequency of collisions. Okay, on that class, correct? Have you write all the points correctly? Or any question you want to ask? Okay, or not? No question, huh? Okay, now next one. Okay, how the concentration of potassium thiosulfate solution affects the rate of reaction in the experiment. Okay, so for this one, no need to compare because the question do not give you 2 experiments, right? Okay, but we still can use the points here. So concentration of potassium thiosulfate solution, Okay, so point number 1. Okay, the concentration of potassium thiosulfate solution is higher. Okay, so point number 2, the number of here no more hydrogen, So here potassium thiosulfate solution class. What are the ions they are responsible for this reaction class? If the concentration is the potassium or thiosulfate class for this one, the number of which ions? Potassium ions or thiosulfate ions? What do you think, class? Darren, what do you think? Kansing? If these two, concentration of potassium ions or thiosulfate ions. The other one will be acid, all right? Okay, you see, acid. Okay, sulfuric acid. So it will be, if you refer to the not system, thiosulfate, right? Okay, sodium thiosulfate. So it will be thiosulfate ions. Okay, thiosulfate ions. Okay, so the number of thiosulfate ions per unit volume increases or is higher. Okay, so the frequency of collisions between thiosulfate ions and hydrogen ions. Okay, increases. Okay, so point number 4, the frequency of effective collisions between the thiosulfate ions and the hydrogen ions increases. Okay. Any question, class? Okay, huh? Okay, next one will be temperature. If temperature set 1 and set 2, let's see. Set 1, set 2. Set 2, higher temperature. Set 1, higher temperature. Set 2, lower temperature. Okay? So calcium carbonate and the hydrochloric acid. So class, what do you think is the temperature? Which one will be higher temperature? Is the acid or the calcium carbonate? Okay, normally it's the acid now. Acid, higher temperature. Okay, so we explain based on the factor of temperature. Okay, so the temperature, point number 1, the temperature of reaction mixture in set 1 is higher than set 2. Okay, so point number 2. Okay, the kinetic energy of hydrogen ions, still the same, hydrogen ions in set 1, set 1 is higher than set 2. Okay. Point number 3. Okay, so the frequency of collisions between what? Let me check. Acid and the calcium carbonate. Here, calcium carbonate, no need to mention what calcium carbonate. Okay, and hydrogen ions in set 1 is higher than set 2. Okay. Point number 4, again, same frequency of effective collisions. Okay, between calcium carbonate will be the same. The only difference, point 3 and point 4 collision, this one is the effective collisions. Okay, so I hope you can remember, you can remember these two. Okay, Now point factor of catalyst. Okay, here collision. We are using the collision theory here. So set 1 and set 2. Okay, so which one got the catalyst class? Set 2, right? Set 2. So here's the manganese 4 oxide powder. Okay, so we use the points in the knots just now. Okay, so manganese point number 1. Okay, manganese 4 oxide. Okay, presents as a catalyst for the reaction, of hydrogen peroxide solution in set 2, but not in set 1. Okay, so this one is a suggestion only. You can use the different sentence but same meaning. Okay, set 2 has a manganese 4 oxide as a catalyst, but set 1 don't have. Also you can write like that. Okay, point number 2. So what the catalyst can do? So manganese 4 oxide, okay, lower the activation energy for the reaction between hydrogen peroxide molecules in set 2. Okay, so point number 3. Sorry, yeah, you mentioned about more colliding particles, right? Okay, here colliding particles here. You can mention about the colliding particles, or you want to mention about the colliding hydrogen peroxide molecules also can. Okay, achieve the lower activation energy. Okay, point number 4. Okay, so here for the catalyst, no need to mention about the frequency of collisions. So we directly mention about the frequency of effective collisions. So this is the only difference for catalyst compared to the other factors. Effective collisions, okay, between hydrogen peroxide molecules in set 2 is higher than set 1. Okay, so here directly you mention about the frequency of collision. So now the particles is the hydrogen peroxide molecules. Okay. Any question you want to ask us? So this collision theory will be asked every year in the SPM. So you must learn how to write it correctly. And then actually the points are fixed. As long as you can remember, then you can score this question easily, especially in the essay questions. Okay. Now we try to solve the questions at the back. Okay, we tried these questions. Okay, sulfuric acid here. Complete the table above. Okay, so 0.2. This one is 0.2. Okay. So step number 1, class. If sulfuric acid concentration is 0.2, how about the concentration of hydrogen ions? What is your idea? What do you think? Can type your answer. If this one 0.2, how about this one? Is it the same or different, class? Okay, will you say same? Okay. Any other answer? Is it the same? The concentration of the hydrogen ions in the sulfuric acid, is it the same? 0.2 or different, class? Okay, different, Janice. Okay, so what is the value if you say different? If different, what is the value? 0.4. 0.4. Okay, why? Why is 0.4? Yes, the answer is 0.4. Why? Anyone? 0.4. Okay, why? Because sulfuric acid is the diprotic acid. Diprotic acid. So record down. If sulfuric acid, when ionized in water, it produces 2 moles of hydrogen ion, sulfate. So if here 0.2 mole, here will be double because here double 0.4 mole per cubic decimeter. Okay, nitric acid. So this one is, we call it diprotic acid. Diprotic acid. Okay, nitric acid is a monoprotic acid. Okay, so if here 0.2, here also 0.2 with set. Okay, so compare the initial rate of reaction between set 1 and set 2. So based on this, which set has a higher rate of reaction? Set 2, right? Sorry, not set 2, should be set 1, no? Set 1 has a higher rate of reaction than set 2. Okay? So explain the answer based on the collision theory. Okay, I think this one just now we have discussed already, the sulfuric acid one. Okay, will be the same. So the colliding particles, it will be magnesium. Now it will be magnesium atom collide with sulfuric acid. So this one will be hydrogen ions from the acid. Okay, no matter sulfuric acid or nitric acid, will be the same. So magnesium atoms collide with hydrogen ions. Okay, so this one I leave it to you. Okay, next. This one is a reaction. Okay, now I would like you to try this question number 2. Okay, everybody you try. So after this, we discuss together. Okay, class. Now we check. Okay. So A, what is the ionic equations? So zinc, so this one like this, it's very simple. Huh? If you see the acid, so directly you change to hydrogen ions. Okay. So this one is zinc. Okay. So meaning that zinc maintain hydrogen will be two hydrogen ions. So produce zinc ions and then hydrogen gas. Oh, okay. So later the collisions will be between the zinc atoms and then the hydrogen ions. So how can the curve 2 be obtained? Curve 2 here, class. So what do you think, class? How to get the curve 2? Which the activation energy is lower? Huh? Lower activation energy. So how to obtain the curve 2? Any idea? We add in what? What happens to the activation energy, class? Curve 1 is the original, huh? Curve 1 original energy. So meaning that activation energy is original. Curve 2 activation energy is lower, right? Lower activation energy. So how to lower the activation energy, class? How to lower the activation energy? We add in catalyst, right? We add in catalyst. So what is the catalyst, suitable catalyst for this reaction? So record down this one. Add in copper to sulfate solution as catalyst. As catalyst. Okay. So, which curve will give a higher rate of reaction? Definitely curve 1 or 2, class. Maybe curve 2 lor. Okay, because lower activation energy. More collision can overcome the lower activation energy easily. Okay, huh? Okay. So collision theory. So we use the factor of catalyst, all right? Okay, so again, we try one more time. So you can refer to the one we discussed just now, almost the same. Okay. I think this one you can refer to this one or exactly the same, right? Exactly the same. This one here. Carbon 2 sulfates, right? Okay. Is it zinc and sulfuric acid to be the same or not? Yes, zinc and sulfuric acid. Okay. So you can directly use this point, 4 points. Carbon 2 sulfate present as a catalyst for the reaction between the zinc and sulfuric acid. But in the curve 2, but not in the curve 1. Okay. And after that, carbon 2 sulfate lowers the activation energy for the reaction between the zinc and the sulfuric acid in the curve 2. So more colliding particles achieve the activation energy. So this one, no points. Directly, you go to the frequency of collisions between the hydrogen ions and zinc atoms in the curve 2 is higher than curve 1. So rate of reaction in the curve 2 is higher than curve 1. Okay, all class? So you always can refer there. Okay, now we try to do some objective questions. Okay, there are 7 objective questions. Okay, I'll let you try quickly, 5 minutes. Especially question number 4. Everyone, you must know how to solve this question. Question number 4. Okay, class, now we check. Okay, there are 7 questions here. Okay, question number 1, which one is true? About the effect of higher concentration of the reactants on the rate of reaction. Okay, so here is a concentration, concentration factor. So which one is correct, class? Can you type in your answer? What is your answer, class? Question number 1. Anyone? You have answer? Okay, number of reactant particles per unit volume of increases. Yes, this one. Okay, correct. Concentration. Number of reactant particles per unit volume. Okay. Here the particle we don't know because here not mentioned. So we take this one. Okay, number 2. Lowest which reactant has the lowest activation energy when reacts with water? Okay, so what do you think? Lowest activation energy. So this one I think is a hot question. How do you apply this one? Lowest the activation energy. What is the answer? Any idea? Crystal, what do you think? Wen-Xin, what do you think? You don't know. Okay. Lowest activation energy, okay. Lowest activation energy means that the reaction can occur very difficult to occur or very easy to occur. Lowest activation energy meaning that the reaction can occur easily, right? Easily. In other words, okay, it is very reactive. Very reactive means the reaction can occur very, very fast, right? So which one? Yes, it's B, because potassium is the most reactive among sodium and lithium, right? They are very reactive, but this one is the most reactive. So lowest activation energy, boy. Okay, so lowest activation energy here refer to the most reactive, because it can react faster. Okay, number 3. Effective collisions. What is mean by effective collisions? What is the meaning of effective collisions? Don't use successful collisions and so on. We use the effective. Effective. Yes, collisions that result in a chemical reaction. Yes. Okay. Meaning that the collisions that give a result. Okay, give a result. Okay, number 4. Okay, so number 4. Before we look into the question, okay, what is the answer? What is the answer? Which one is correct? Reduced powder, volume, concentration. Okay. Which one is your answer? A, B, C, or D? Okay, you have to know how to analyze these. Okay. Let me see. Darren, what is the answer for this? If you don't know, you let me know. Willie, what is your answer? Question number 4. Suyang, what is the answer? Or Janice, Wen-Xin, Crystal, Kang-Xin. What is the answer? Okay, Janice choose C. Okay. How about the others? All choose C? Okay, Suyang also choose C. Okay, how about the others? No, any other answer? Wen-Xin? Okay, we check. Okay, first we look into the rate of reaction. Okay, so set 1, set 2, which one higher rate class? This one powder, then higher concentration, correct? So set 2 higher rate, set 2 higher rate, meaning that the gradient will be steeper. We check steeper gradient. So this one set 1, set 1's higher gradient, steeper gradient. So meaning that A out already, so not possible. Set 2, this one B, set 2 also lower gradient, okay, this one steeper gradient, so B also out, okay. C, steeper gradient, this one possible, meaning that the remaining C and D, okay. Now we want to see whether it has produced the same volume or not. This one different volume, this one same volume. So what you need to see is the number of mole, okay. You need to look into number of mole. Okay, if number of mole for both sets same, the result will be like this. If number of mole is different, then your result will be C. Okay, we check. The number of mole is same or not, class? This one M, this one V, right? We use the MV over 1000. Okay, so what is the number of mole for this? For set 1, 0.005 mole. Okay, how about set 2? 0.005 also, right? Okay, so mole times molar volume 24. So you will get the same one, right? Times 24. This one also times 24. So meaning that the volume of the hydrogen gas release are the same, okay, because the mole is the same. In other words, so this one is wrong because here is volume is different. Okay, this one volume is the same. So the answer should be D. Okay, because number of mole is the same. Okay, because more times the molar volume, you get the volume. Oh, okay. Now question number 5, we quickly go through. Question number 5. Okay, the gradient decrease of with time because what? Why it decrease? Because the reactants used up already, right? Okay, so it's D. Okay, the concentration of the sulfuric acid decreases because used up already. Okay, Okay, number. I think we stop here. We stop here tonight. Okay, we remain question 6 and question 7. Okay, we continue again next week now. Okay, thank you for your attention tonight. Okay, thank you all. Good night to all of you.